Hi folks, as I promised in the previous episode, today I want to show you a couple of things you can do with IPv6 auto configuration that you can't do or can't do as easily with IPv4 using DHCP or whatever. So first off, I got myself a whiteboard. So now I'm a real professional technical blogger, right? Because every respectable blogger has something like this. I've actually drawn the network setup I want to show you. I've got 3 subnets drawn W. Richard Stevens style, like Node coax cable. It's more convenient actually and easier to visualize like this than the diagrams you usually see these days, where they're centered switches or VLANs and then long connections go on there. Anyway, every subnet here has an IPv6 host connected to it. First one running Debian, second one running FreeBSD, third one running Windows 7. We won't need the Windows 7 for today though. And I have 3 routers, A, B and C, which are connected to all these networks. First one is running Debian, second one is FreeBSD, and third one is not Windows, it's iOS, and not Apple iOS, but Cisco iOS, of course. So here's the actual setup. Brought out my real world actual old Cisco 1800 router. I've got the switch to make my notebook have more network interfaces than just one, so I got the 3 I need. The external hard disk where I keep everything on, and of course the notebook everything's connected to. And with the setup I've shown you, what I want to do is show you how to do redundant router configurations. So if one router fails, the hosts will automatically fall back to another host. Let's take a closer look. Okay, what do we need? First of all, we need our hosts. As I said, I'm not going to use Windows today because it's just inconvenient for this sort of stuff. Here I've got Debian. And as you see, it's got an auto configuration address 2001 DB8, which is documentation prefix, 101 to simulate global routing prefix for me. Subnet is 1 subnet ID, and then whatever it uses from the MAC address. Now here's the FreeBSD, and the first thing to do is check if they can ping each other. Or, well, might as well if config xn0. Take a look at the network configuration here, and what you see is it's in a different subnet. Subnet ID here is 2, while on the Debian it's 1. So let's try ping 6 2001 DB8 101 1216 3EFF FE51 FF21, and of course it doesn't work. Why is that? Chances are very good it's a typo in there. So it's 2001 DB8 101 1 216 3EFF FE51 F21, and it actually works. Now, of course, this was only for educational purposes, but seriously, if you try this, or if you type in addresses while you talk and you have some sort of audience, it never works the first run. It's one of those things you'll eventually learn with IPv6. If you use addresses instead of DNS names, always first thing to do is check for typos. It always works like this. Murphy always gets you. Okay, so let's take a look and see what happens if a router fails. Now, one of the not so nice things with FreeBSD is if you do netstat -rnf inet6 and take a look at the routing table, it only shows you the active default router. Despite the fact that we have 3 default routers, all 3 routers we have here, which are in these windows. Sorry, it's a bit cluttered up because, well, if you try to squeeze 6 consoles on a single single monitor display, it's just gonna get cluttered. Okay, on the Linux side, however, if you do an IP-6 route show, you actually see all three default routes. Problem here is it doesn't exactly tell you which one it's currently using. Normally it's the first one on the list, but never actually found out if that was just accidental or if it was meant to be this way. Okay, now what I want to do now is kill the default router that we've been using for the ping, and then, well, start the ping, kill the router we've been using for the ping, and then see what happens. And as you see, the default router here is the one for FE5, which is, I don't know, let's take a look. For FE5, bingo. So let's ping our FreeBSD system, ping the Debian system from our FreeBSD system, and while we do so, oh, that's not the one. That's what I need. XM pause router B. So I'm now pausing the router, and as you see here, the ping stops, which is what you'd expect because the router is gone. Now, good magic takes a couple seconds, as anything good really, and so does this failover. The problem here is that the default timing parameters, which I haven't actually changed, take up to 45 seconds for the failover. So somehow I have to keep talking for up to 45 seconds. Well, if I'd been lucky, it would have been 15 seconds only, but that should have been over by now. Ah, there we go. And as you see, let me stop that so we get the timing. So that's 55 minus 18, so that's 46 seconds. So that's been no, hang on, 36 seconds. Yeah, that's reasonable. So after 36 seconds, the ping works again. This is a bit of time, obviously, possibly long enough for people using zip phone at work to pull up their cell phone and call support via mobile. But for a lot of other things, this is actually enough. All you have to do is set up your routers as advertising routers. I'm not going to go into that detail into that. If you really want to know about that, leave a note in the forum or send me an email or whatever, and I'll do another episode on how to set up a router for IPv6. But it works. It is fast enough not to interrupt a running TCP connection. These 45 seconds are shorter than the final TCP timeout, and it just works. Now, if you're a professional network administrator, you probably say, yeah, but you've got HSRP or VRRP or CARP or whatever, some sort of first hop router redundancy protocol, which can do this significantly faster by easy order of magnitude. And if you combine those with something called BFD, which discovers that a peer router is down within about 50 milliseconds if you force the timing parameters to that. Yes, those are definitely superior, but you need proper network equipment, and you need somebody who knows how to set these up and run them. VRRP, one I've taken a look at some time ago, is basically a lightweight cluster setup. It's not like a full-blown application cluster where you have 2 compute nodes and then you have 2 storage devices. It gets away without the storage, but it's still basically a cluster. 2 machines monitor each other, and if one decides the other one is down, it tries to take over a shared virtual IP address and whatnot, and all sorts of funny things can happen and go wrong, like pretty much with any cluster. If you want to use these, go for it. If you're a professional network admin, then you should be familiar with these things. And they're not rocket science, but it's not exactly the sort of stuff you want to set up. Spend 3 days on getting everything to work, testing everything and sorting things out, then have it up and running for half a dozen months or half a dozen years, and then things go wrong for some reason. It takes 2 or 3 days to figure out what you've done when you first set it up and what it actually happened to make it fail while in production. So that's why I like this stuff, and you can't do it with DHCP with IPv4. So that's actually, I think, pretty cool. Not for the professional environment, but for those lower life forms who want to have internet at their homes, right? Okay, that was number one. And number two is related to a situation which sometimes happens. Let me grab my markers, because now I'm going to do some live drawing here. No, take the red one. Which is about somebody connecting to our network a rogue router. A rogue router. A router that doesn't belong there, which starts to advertise itself as a default router and tries to advertise prefixes. You might think, okay, but why would that happen? I mean, okay, fair enough. We've had lots of problems with people introducing, for example, Wi-Fi access points into networks which had a DHCP server installed, but a router? Well, actually, this phenomenon is not quite as unusual as you might think. At least it was some time ago, when a lot of people had no other choice when they wanted to try out IPv6 but to use a tunnel. So they take their notebook, install a 6-to-4 tunnel or whatever, and because they're preferably undergraduate students, take it to a lecture into an auditorium hall and connect it to the network there, and forgetting to turn off the routing feature and the 6-to-4 tunnel, they'd start to advertise themselves as IPv6 default router. And some people working in that sort of environment actually decided that this is not something they want to live with. Especially when Wi-Fi enters the game. Yes, there are ways to deal with this. For IPv4 and DHCP, you've got something called DHCP guard or whatever, which is run on a switch and basically makes the switch block DHCP from all ports except for those you actually whitelisted. And you got the same for IPv6 router advertisements. Good, at least on some switches. Some of the more expensive switches. Some of the more expensive switches that have been set up to use this feature as well as being shipped with it. And the reason why I don't like it very much is because it violates the network layers again. A real switch is meant to be layer 2, not layer 3. But auto-configuration, as well as DHCP, is layer 3 or layer 7. So a different layer than what a switch should actually pay attention to. And as I've explained before, yeah, violating network layers frequently gets your immediate problem solved, but eventually it'll backfire badly. So the nice thing is, with auto configuration, all router advertisements, except in rather specific cases like ISO-TAP setups, are sent to the all node link local multicast addresses, so all nodes receive them. And that means you can set up a fancy high-end computer, like a Raspberry Pi if you want, to listen for router advertisements. And if it detects a router advertisement, you can trigger some action. You could do that yourself, set up a packet filter which logs router advertisements, pipe them output to a script that checks for MAC addresses, for example, and then does whatever to deal with a rogue advertising router. However, there are easier ways to do it than that, because somebody actually went through the trouble and wrote a little program to take care of these things. It's called the remedy, the Router Advertisement Monitoring Daemon, and I'd say we take a quick look at it. Here we go. Okay, so first off, I've restarted router B again, and I've started a virtual machine containing having the remedy installed. I haven't started it yet, and that means if we check for routes here on the Debian machine, it should show all three routes. IP-6 route show, and we see default, 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 three default routes. That's what we'd expect. Now, the remedy configuration. Bad news is this is XML, but well, we'll have to live with that. I've got a list of 3 MAC addresses. These are the MAC addresses of the Cisco router. And for these authorized routers, I have a rule which does nothing. For all other router advertisements seen, the remedy will use a clear routine, which basically means it will send out a router advertisement which has a router lifetime of 0 to disable these routers as a default router. And if we take a look at Wireshark, what we can do with FreeBSD is we can do on RT-sol-A a router solicitation on all interfaces. And when we do that, we see the router solicitation and 3 router advertisements from 3 different routers. Now, when we start the remedy, we can actually do that with -D in debugging mode, so we see what it's doing or what it thinks it's doing. When we send a router solicitation, received a packet from blah 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 blah. That's the Cisco router, by the way. Matched rule 1, which says do nothing. Okay, received another packet from another router, which matched rule 2, which says clear that route, and it does, and from the third router as well. If we take a look at it in the Wireshark, let's stop that first. What we see is a router solicitation, then we see 3 router advertisements, and these have a router lifetime of 1800 each. There and there. However, then the remedy strikes back, sends router advertisements with a router lifetime of 0. And again, router lifetime of 0. It does preserve the prefix information because you can't easily revoke that. That would be a very simple way to get yourself in some real stupid trouble. So you can only reduce the valid lifetime of routes to 2 hours, but it sets the preferred lifetime to 0 already, which is about as good as it can be at this point. And now if we take a look at the Debian system, which lets us see all the routes it has and all the default routes it uses, we see there's only one default route left, and that's through FE80::feed 3, which is to Cisco. By the way, nice thing with Cisco setup is that you can easily set your link local address, so it makes it reasonably straightforward to identify your router here. So, again, this is nothing very fancy, but it is something tremendously useful in a number of situations. That's what I like about it. The remedy is fairly simple, except for using XML for configuration syntax, but okay, whatever. And it works. So if you run a decidedly hostile environment, like, well, the worst ones I've been kind of dealing with were student dorms, probably the worst thing that can happen to you in your life. even worse than being in charge of or doing first level support for consumer grade ISP, I guess. Anyway, student dorms, lecture halls in universities, and conference setups. Like over the holidays I've been to some kind of conference, and they've had lots of fun, lots of people running around in black t-shirts doing funny things to computers. And yes, the network was at its limit a lot of times. I mean, it's radio, a lot of it was radio, Wi-Fi, and you only have limited amount of bandwidth in the radio spectrum. So in those environments, these tools are tremendously helpful. And if you want, there's something cool you can also do with Remedy. You can also tell it if this rule matches. So we have a rogue advertising router in the network, then run this script. And that script can take the MAC address from the offending router, then take a look at your switches, figure out on which switch, on which port the rogue router is on, and turn off that port, for example. I mean, after all, it's just defending servers for everybody else, right? And if you're a system administrator or network administrator, that's the sort of stuff you do. You sit at your computer, do something, and stay there rather than trying to run around and find whoever did whatever to your network. You just sit there and wait for people to, oh, my broken, can you fix it? Yes, please send it over. Okay, where is the mod? Okay, now it's fixed, thank you. I like that. Okay, so much about IPv6 things you can do with auto configuration. Hope you enjoyed it. If you have questions, comments, want to discuss, want to tell me that, yeah, but you should still use RA guard, you should still use BFD with HSRP or VRLP or whatever, fine. Come over to the forum and we'll talk it over there. It's at www.stapler-it.com/BIVBlog/23 in this case. And if you liked it, you could do me a favor and give it a thumbs up on YouTube. Okay, see you again soon. Bye.